Dr. K. Paranivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the series of lecture on chemistry of environment. In the previous class we discussed about atmospheric chemistry and we discussed some of the important air pollution episodes, namely photochemical smog formation, greenhouse effect or global warming, and then ozone layer depletion. And in this we are going to discuss one more important air pollution episode, namely acid rain. We all know rainwater is one of the purest form of water available, and now due to various industrial activities it is reported that the rainwater is contaminated because of the air pollutants present in the atmosphere contaminate the rainwater. And in the presence of atmospheric moisture in the atmosphere, gases such as sulfur dioxides or oxides of nitrogen resulting from industrial emission turn into droplets of pure acid floating in smog. Usually this particular acidic water is normally known as acid rain. Generally, carbon dioxide present in the atmosphere is also a weak acid. It also will get dissolved in the rainwater, but if you look at the pH, it may decrease maximum to the pH value of 5.6, that is slightly acidic, because carbon dioxide also will get dissolved in the rainwater and gets converted to carbonic acid. Under that situation, the pH will not drop below 5.6, that is considered to be normal, even though the pH of the normal water is to be neutral water to be 7, 5.76 is considered to be acceptable. But now the oxides of sulfur and nitrogen resulting from the industrial activities, especially from nitrogen dioxide, get dissolved in rainwater and comes in the form of acid rain, where the pH is reported to be below 5.6, and it varies widely in the rainwater pH due to contamination from these acidic gases. Below, even up to close to pH value of 2 have been reported. Many places 3, 4, all these things is quite common, where these type of uncontrolled oxides of nitrogen and sulfur are emitted into the atmosphere. So much of this oxides of nitrogen and sulfur entering or liberated into the atmosphere as sulfur dioxide and oxides of nitrogen gets reacted as per this equation. For example, sulfur dioxide, even with the molecular oxygen is present with the water vapor, it is converted into sulfuric acid, which is a very, very strong acid. So similarly, nitrogen dioxide also will react with the molecular oxygen in atmosphere and moist water, it is there, it also gets converted into strong acids like nitric acid. Okay. So this is a main reason for rainwater being very acidic. Okay. And sometimes it is also possible hydrochloric acid emanated from certain industrial activity that also will contribute towards acid rain or acid precipitation. Okay. And that is now one of the major environmental issues in many places. And if you look at the contribution, sulfur dioxide contributes 60 to 70% and rest is by nitrogen dioxide. About 30 to 40% nitrogen oxides contribute towards acid rain. And this is not a local problem or something. This problem have been observed throughout the globe. For example, as shown in the diagram, sulfur dioxide gets converted into hydrogen peroxide or molecular oxygen into sulfuric acid, and SO3 sulfur trioxide, if emanated from certain industries or reaction with the molecular oxygen, can convert it into sulfuric acid again. So, the pH in the cloud, pH may be 5 or something, but because of this oxidation of nitrogen and sulfur, they get reduced to pH 3.6 or 4.2. Cloud pH is 5, but with these type of oxides will contribute to 3.6. Ultimately, it will be below this normal rainwater, which is maybe above 5.6, but in many places it is all between 3 to 4, or some places some extreme events have been noticed. Even pH as low as 2 have been reported, and this is what we collectively call it as acid rain. Because the rainwater, it is a precipitation, it includes rain, mist, snow, everything whatever comes will be acidic in nature. These precipitation is acidic in nature. What are the consequences or effects to the environment? This is what very important. Even if you consider forest and lakes, which are all far away from industrial activity, is also reported to be damaged by acid rain, because one of the important parameter for air pollution or meteorological parameters, wind. This is very important, and the wind speed is strong. It takes the pollutant far away from where it is emitted, and many forests and lakes also contaminated, even though they are far away from industrial activities, because of the main reason is wind. They carry all the pollutants far away wherever favorable conditions are there, and gets reacted with this rain or snow, and ultimately make them acidic. So, because of this, the forest lakes contaminated, and the forest, if it is acidic, it acts as a kind of sterilization agent, and normal growth is prevented. Same thing, acidification of lake also, which is very toxic to the flora and fauna, and especially fish is mainly affected. Throughout the globe, it is reported many lakes there is no fish at all because of the acid rain, especially the eggs are affected, which is calcium based one, and acid rain attacks very easily, and ultimately reproduction of fish is stalled. And same thing with respect to all the flora and fauna, even natural algae material is also affected because of the acid rain. Another problem is leaching of nutrient cations, heavy metals from soil, rock, as well as the sediment, lake and stream by this acid rain. Because the acid rain, which is predominantly H plus ion, and it will go and leach out all the cations and heavy metals present in the soil, sediment, etc., and ultimately H plus goes there, and cations and toxic metals comes out from this soil and rock material. This is one of the another major issue in which the nutrients, everything is lost because of the acid rain, which ultimately leaches out the important cations and other things. And direct phytotoxicity to plants also in many places again reported because of the leaching, where aluminum is one of the important constituent of the soil, is liberated because of the acid rain in high concentration, and ultimately the high amount of aluminum makes this plant material phytotoxic, and normal growth and yield, everything is affected. So, overall if you see, there is a reduction in forest and crop productivity due to the acid rain, and this is many places, not in a single places. As I mentioned here, the wind carry all these pollutants far away also, and many places this is affected, not only industrial area, far away places also. And these type of acid rain also causes even health issues, especially lungs is affected because of the airborne acids. Suppose we are happen to breathe, and our lungs also will get affected. And above all, limestone, which can very easily react, which is limestone, nothing but a allotrophic form. Our marble is one of the important thing, and many places metals also corroded. This one, our famous Taj Mahal is one of the example, where in which the marble is attacked by the acids, and ultimately it causes corrosion. Normally we will call it as cancer, marble cancer, these type of acid attack by acid rain. And in Taj Mahal, this has happened because of the nearby Madura refinery. They liberate a huge amount of sulfur dioxide due to the industrial process action, and ultimately the sulfur dioxide comes and reacts with this and convert this marble, which is originally calcium carbonate in a special allotropic form, gets converted into calcium sulfate, where if you consider the solubility of calcium carbonate and calcium sulfate is more soluble, especially in marble. Calcium carbonate, which is a very special allotropic form of calcium carbonate, solubility is very, very low. But in the moment by acid attack, it is, if it is converted to calcium sulfate, which is again considered to be insoluble, but if you compare the solubility of calcium carbonate and calcium sulfate has more, and ultimately calcium is leached out of this marble. That is normally known as marble cancer. So, dissolution of metals such as lead and copper from water distribution pipe, and corrosion of exposed metals, and many places bridges and other things is also gets corroded because of this acid leaching property. And many monuments also, including our Taj Mahal and other things, also gets corroded because of this thing. So, it causes lot of damage. If you look at it, monuments, health, and above all flora, fauna, including forest, everything is affected because of this acid rain issue. So, to sum up, if you see, acid rain again is one of the very important anomalous episode in which the pollution is mainly because of liberation of oxides of nitrogen and sulfur, where in which they all gets converted into strong acids like sulfuric acid and nitric acid, which ultimately affects the material, forest, plant, everything ultimately affected. The crop yield is normally affected, and especially monuments and bridges, leading to loss of economic loss also due to this acid rain. So, we have to be very, very careful in controlling the precursor material, namely oxides of nitrogen and sulfur, carefully, so that we can prevent the formation of acid rain in future. See what is air pollution, how these air pollutants are classified, and what are the effects, and how to control and brief, we will discuss during this series. So, to start with, what is air pollution actually? Presence of foreign substances in air, mainly because of our activity. We release lot of pollutants, ultimately they end up in atmosphere and causes lot of issue. That is normally known as air pollution. To elaborate this, the addition of harmful substances to the atmosphere resulting in damage to the environment, human health, and quality of life. This is normally known as you can consider as a kind of definition for air pollution. Crude presence of foreign substances in air, because of human activity, and these substances, if they cause damage to the environment, human health and quality of life, we can call it as air pollution. Our IS also defined this air pollution. As per the IS, air pollution is defined as presence in ambient atmospheres of substances generally resulting from the activity of man in sufficient concentration, present for a sufficient time under circumstances such as to interfere with comfort, health or welfare of persons, or with the reasonable use or enjoyment of property. This is normally the definition as per the IS standard for air pollution, which clearly explain all these things. Mere presence of particular substance is not considered as a pollutant. At the same time, it should cause some kind of discomfort to us. Maybe it may cause some environmental damage, health or quality of life. Or to start with, whatever we enjoy, if there is a enjoyment of the property or whatever it is, if there is some issues in the normal one, because of the presence of these air pollutants, is generally considered as air pollution. And throughout the globe, many countries they started, especially we discussed about London smog and London, that is what air pollution, they started seriously how to control this, and in fact they initiated or enacted law to preserve the air. And many countries throughout the globe started. Even in India, we enacted a Air Act in 1981 to protect the public health. In the year 1981, Government of India also enacted Air Act, and many air pollutants are controlled to take care of the welfare of the people. So, before going to what are the air pollutants, all these things, see how these air pollutants are classified. Okay. And classification, there are 2 or 3, 4 ways of classifying the air pollutant. We will look at it each one by one, how they are classified. The first way of classification is based on differences in their physical or chemical characteristics, and accordingly this is classified into main 2 types. One is aerosol, the other one is gases and vapors. And if you see the aerosols, these are all tiny particles usually dispersed in gases and include both liquid and solid. Okay. And air pollutant terminology related to atmospheric aerosol include dust, fog, fumes, haze, mist, particulate matter, smog, smoke and soot particles. All these things comes under this aerosol, and really if you look at it, all this comes under the category of what is called colloidal materials. Colloidal things, particle size less than 100 micrometer, in which liquid or solid particle will disperse in the medium of air. So, these all these aerosols comes under the category of colloidal particle, including soot particle, smog, whatever we discussed, particulate matter, mist, fumes, all those things is a colloidal particle in which liquid or solids are dispersed in the gaseous atmosphere. So, this is one category. The second one is gases and vapors, okay. And these are all composed of widely separated freely moving molecules which will expand to fill a larger container and exert a pressure in all directions. Okay. That is gases and vapor. If you see the difference between what is gas and vapor, a true gas, okay, is the one in which it is removed from the liquid state, that is the temperature of the substance is above its critical point. That is very difficult to, under normal circumstances, liquefy them, and these are gases like carbon dioxide, carbon monoxide, etc. Normally, they will be present as in the gaseous form, whereas a vapor is different from gases. Is a substance in the gaseous state which is not far away from a liquid. That is, it can be condensed to a liquid relatively easily. So, this is what the difference between gases and vapor. Vapors can be easily condensed, and from the gaseous form it can be converted to liquid form, whereas a true gas in which it is very difficult to liquefy them in the normal circumstances. So, that is the difference between gases and liquid. So, based on the physical state of this thing, we can classify them and air pollutants as aerosols or gases and vapors. This is one category. The second way of category is based on the origin of the pollutant, and here again whether it is originated from the mobile source or stationary source. And mobile sources of emission include automobile, trains and aircraft. And here again we use all fuels, burn them to run this automobile and trains and airplanes, and because of the combustion again we emit large amount of pollutants, and being mobile in nature, this is from a mobile source. The second one origin is from a stationary source, okay, which include all other sources except a mobile one, that is a power plant, thermal power station, and chemical manufacturing industries like aluminum or metal processing industry, or the one in which they are all stationary, but they continue to emit pollutant, air pollutants. This is called stationary. And again these mobile and stationary, depending on the where it arises, may be a point source or area source. This origin can be classified. A point source, that is defined as a stationary source whose emissions significantly impact air quality. Again in the stationary we have checked, there is a thermal power station is one, significantly it should impact it from a particular point source, whereas area source is different from this, and in fact these are those that individually do not have significant impact on the air quality, but are significant when viewed together. Okay. Combined everything, definitely then that particular area becomes a air polluting source. For example, airport, you just take one aircraft may not be much, but huge number of at a time 100 airplanes are coming and taking off landing, then it becomes a area source, that is the airport. Similarly, open burning, some one or two houses in villages they may burn it, but it may not impact it, but everybody started burning some material, open burning, as in the time of Bohai it is viewed as a area source pollution. So, definitely these type of open burning should be stopped, and this is a practice in Tamil Nadu and other parts of India, where the festival time, especially Bohai before Pongal, we have the habit of burning it, and this is not a one in which almost all cities are polluted. This is normally becomes as a area source, and many example like this. And the other way of air pollutant classification is how they reach the atmosphere. So, air pollutants are classified here, how they reach the atmosphere, mainly based on two types. One is a primary air pollutant, the other one is secondary air pollutants. Okay. From the source or origin, how they reach the atmosphere, it is classified into two types. One is a primary, the other one is secondary. Let us see what is this. And primary air pollutants are those that are emitted directly into the atmosphere from an identifiable source. For example, which include volcanic ash. Due to volcanic eruption, some ash may be emitted, that is one primary pollutant, there is no change in it. Similarly, carbon monoxide, carbon dioxide, sulfur dioxide, oxides of nitrogen, everything they are emanating from this various activities like transport, mobility or burning of anything. carbon monoxide is again incomplete combustion. This is one of the source. And carbon dioxide, sulfur dioxide, they are all emitted from a particular source as such. There is no change in it, they remain for some time. So, these type of pollutants are called primary pollutants. And coming to secondary pollutants, and these are the one that are produced as a result of chemical reaction in the atmosphere, or in other words, they are emanating from the primary pollutants. The primary pollutants which will interact in the atmosphere with the summer constituents, and ultimately they generate new pollutant, that is called secondary pollutant. Already we have discussed all those things in the previous lecture series on atmospheric chemistry. Just I want to highlight one or two. So, the example for secondary air pollutant is ground level ozone. The ozone layer depletion itself, I explained there are the two sides effect of ozone. One is good ozone and bad. If ozone is present in the stratosphere, it is considered as a good, but at the same time ozone is present in the troposphere, which is considered as a bad one. We all this effects of this ozone in troposphere were discussed. So, ozone again, it is not directly emitted from any particular source, it is all through reaction, as we discussed before. It is formed because of mostly nitrogen oxides have a very good role in generating ozone in the troposphere. Another well known example is photochemical smog, that is peroxyacetyl nitrate formation. Already we discussed during this series of lecture, is again an example for secondary air pollutant. Another one is acid mist. Just now we have discussed about acid rain. This acid mist again emitted as a sulfur dioxide, oxygen, nitrogen, again they are all converted into mist in the atmosphere that comes as a kind of colloidal acid mist, which is again an example for secondary pollutant. So, this primary secondary is another way of classification. And in the case of secondary pollutants, suppose we want to contain it, the best way is to stop the emission of precursor material to the pollutant that was actually generally regulated. For example, already we discussed the photochemical smog formation, how we can control it through the minimizing the precursor material, namely hydrocarbon and oxygen nitrogen. Through a catalytic converter, we can convert this or minimize this photochemical smog by converting the hydrocarbon into carbon dioxide, first stage, and the second one using a catalytic which will convert the oxygen nitrogen into nitrogen, so that we can prevent the formation of the pollutants like photochemical smog, which is an example for secondary air pollutant. And another classification is based on source. Two type of sources. One is anthropogenic sources, which is mainly responsible for air pollution. Okay. In fact, all the air pollution issues started because of this one. The moment we start making fire, we learn how to make fire, that is the origin for all this air pollution. So, anthropogenic sources, there is a human activity, and now mainly it is a very huge number burning of different kinds of fuel, not only these toxic pollutants like sulfur dioxide, oxygen, nitrogen, even the main culprit responsible for global warming and the consequent climate change is carbon dioxide, which is again comes from this burning issue only. And to quote certain example for anthropogenic sources, we have like a stationary source remain as such, like a power plant, manufacturing facilities like aluminum or copper smelting, cement manufacturing, or waste incinerator, all example for kind of anthropogenic emission. And mobile sources also, motor vehicle movement, marine vessels, aircraft, all these things again because of anthropogenic activities. Fumes from paint, hairspray, varnish, aerosol spray, and other solvents operated in many industries, etc., and many more, which are all because of anthropogenic activity as anthropogenic source. The other classification is natural. The air pollutant may come from natural way also without human interaction, and dust from natural sources usually from the vegetation and decay, methane again from the degradation of food and animals like cattle, and also we have radioactive emission like a radon is also possible, and smoke and carbon monoxide from forest fire, and volcanic activity which produce sulfur, chlorine, ash, etc. So, these are, so we can classify the air pollutant. To sum up, what is air pollution and the different ways of classifying the air pollutants we have discussed, depending on whether it is natural or anthropogenic, again based on primary pollutant or secondary pollutant, and based on mobile or stationary source, and aerosol or gases, and again based on the nature of chemical material like inorganic or organic. So, these are the various ways of classifying the air pollutants. So, in this session we discuss about acid rain, the formation, effects, etc. we discussed. Again, to start with, what is air pollution, the standard definition for air pollution, how these pollutants are classified in a different ways based on the source, nature, etc. we discussed, which gives very good idea about to launch onto what are the different type of air pollutants we are going to discuss in future. With this, I will stop here, we will continue. Thank you.